Hello everyone. Today in the chapter Carbon and its compounds, I am going to talk about ethanol, ethanoic acid, soaps and detergents. Ethanol. Ethanol molecular formula is C2H5OH. It is also called as ethyl alcohol. Ethanol is a colorless liquid. It is having a pleasant smell and a burning taste. It is highly inflammable. It is soluble in water. Ethanol property we are going to discuss here. First chemical property is ethanol used to react with sodium metal to give you sodium ethoxide and hydrogen gas. And if ethanol is going to be dehydrated, or you can say it is heated in the presence of concentrated H2SO4, it will give us one alkene, which is ethene, along with water molecule. The function of H2SO4 in this reaction is dehydrating agent, which used to remove water from ethanol. Ethanol is used to make for alcoholic drinks. It is an excellent solvent. It is also used in making medicines like tincture iodine, cough syrups and tonics. Another compound is ethanoic acid. Ethanoic acid is commonly called as acetic acid with molecular formula CH3COOH. Its 5 to 8% solution is called as vinegar, which is widely used as a preservative in pickles. The melting point of pure ethanoic acid is 290 Kelvin, and it used to freeze oftenly in the winter or cold climates, and it used to give rise glacial acetic acid. Now let's study some properties of ethanoic acid. Number one is esterification. Esterification is the process where any carboxylic acid containing compound is reacting with alcoholic compound to give you ester and water. Here acetic acid is combining with ethanol to give you ethyl acetate with water, and this reaction used to happen in presence of H2SO4. Ester is also one of the functional group which is having some sets of chemical properties, and the ester's qualities is it is used in making perfumes, giving flavors to so many ice creams and so many other edible items, and ester is a sweet smelling compound. Another reaction if I want to talk about here is when ethanoic acid is reacting with alkali like NaOH. It is giving me sodium acetate and water. Here ethanoic acid is weak acid and NaOH is alkali. So acid react with base to give you salt and water. It is similar like reactions we have learnt in inorganic chemistry. If I tell you about some property of ester, when ester is treated with NaOH and the NaOH is taken in aqueous form, it will give me one salt and water. The reaction where the salt and ethyl alcohol, the reaction where you will feel the ester is reacting with aqueous NaOH and it is also giving you the sodium salt of acid and alcohol. Such reactions are called as saponification reaction. Basically, these are the principal reaction to prepare soaps. Another reaction, ethanoic acid reacts with carbonates or bicarbonates to give you salt, water and carbon dioxide. For example, acetic acid is reacting with sodium carbonate or acetic acid is reacting with sodium bicarbonate. It will give you sodium acetate, water and carbon dioxide. You can say if you are adding sodium bicarbonate or sodium carbonate in ethanoic acid, you will get brisk effervescence due to the evolution of carbon dioxide. Another observation you can also write is that you will feel the odorless and colorless gas is coming out from the test tube. Now let's talk about soaps and detergents. Soaps are long chain of sodium and potassium salts of carboxylic acid. One of the example of soap is sodium stearate having molecular formula C17H35COONA. If I talk about the structure of soap molecule, it is having two parts. A long hydrocarbon chain. This is the long hydrocarbon chain which is water repelling or hydrophobic, and it is soluble in water or soluble in oil and grease also. And the short ionic chain where you used to see sodium ion is present and it is very much attracted towards the water, which is soluble in water and remain insoluble in oil and grease. Now let's talk about the cleansing action of soap. First thing is, we know that the soap has two ends. One end is soluble in grease and another end is soluble in water. The first end is hydrophilic, which is sodium part and dissolving in water, whereas the another end is dissolving in oil or grease. First of all, if we see this diagram, here in this diagram, if I have taken a bucket of water and I am adding some soap molecules, soap molecules used to arrange themselves in a circular way where the hydrocarbon part is pointing towards the center of the circle and sodium part is protruding towards the periphery. So, such structure which has been formed by the soap molecule, such cluster you would say is called as micelle. So many micelles used to form in a bucket of water. Again I am repeating, clusters of molecule are formed where hydrophobic part coming at the interior of the cluster and ionic comes to the exterior part of the cluster. When soap is in the form of micelle, then it is having the ability to clean oil or dirt which is accumulated at the center. Now let's suppose this is the stain which need to be removed. Generally, stain is consisting of oil or greasy particles, and oil and greasy particles are very much dissolve the hydrocarbon part of the soap. The soap usually remain as a colloidal solution and does not repel, or you can say does repel and do not precipitate out. Now, when the soap's particles get attached to the stain, what is happening after brushing, after agitating, you remove the stain, and after rinsing so many times into the clean water, the stain suspended into the water and cloth will get cleaned. The soap solution appear cloudy because the colloidal solution has a Tyndall effect. You must have learnt it. Now, one more important thing I want to talk about is soap does not work when the water is hard. What is hard water? Hard water is the water where we will see the calcium or magnesium chlorides and sulfates are present. When such water is treated with sodium stearate, let's suppose, they used to form, they used to do reaction with calcium or magnesium chloride and sulfates, and they used to form one grey or white color precipitate which is called as scum. So, because of the formation of scum, so much soap is getting wasted and the cloth will not get properly cleaned. The last part is detergent. Detergents are long chain sodium and sulfonic acids. Soaps do not wash well with hard water because it forms insoluble grey precipitate which is called scum. But this detergent does not have any impact on hard water, or hard water does not impact the cleaning property of detergent. It does not react only with calcium magnesium salts. And the last one, if we talk about the difference between the soaps and detergents, soaps are sodium salts of fatty acids, detergents are sodium salts of sulfonic acids, and detergents could also be the ammonium salts of long chain carboxylic acid. Soap used to clean in soft water does not act in hard water at all. Detergent has no impact, or you can say hard or soft water, anything will do with detergent. Soaps do not clean as well as detergent, but means soaps does not clean as well like detergents. So detergents are better cleaner. Soaps are biodegradable and do not cause pollution, but detergents are non-biodegradable and they used to cause water pollution. Thank you.